This video here is a little addendum to the previous one, to discuss a few more tricks maybe and tips in using mechanical. Just getting you started with mechanicals. A lot of developments will be done in the following tutorials. But here quickly. So I really wanted to prove you what I was talking about. It's quite important to appreciate that the values given by software, even if they have got large accuracy, like 2 points behind decimal in megapascal, is nowhere near that believable. So, to convince you, what I'm going to do here, first of all, is I'm going to change the mesh. The mesh, let's change the element size and change it to 4 millimeter. Make it twice as big, so that should have around 8 times less elements. Let's update that mesh. So we have 22, and now we have 4. Not quite a factor, not quite factor 8, but close to it. So the mesh is a lot more rough, and something that's worth keeping in mind is that this mesh is barely acceptable. A good rule of thumb is that it should have at least 4 or 5 elements through thickness. Okay, so this is just the minimum we can end up with. So let's solve. So the stress we had before was around 286 megapascal. Now it's gone. So let's resolve. It should be very quick. It's a rough mesh. And 280, you see? So 6 megapascal difference for the maximum stress. So don't ever quote a stress with points, whatever. Be always wary of the accuracy inherent to the method. And I hinted at that before, but a large part of the art of the analyst consists in ensuring that the mesh is good enough to have converged values. Either way, so I don't know, what would, if we had got hundreds of thousands of elements, what would we get? 290, 285, 300, still, it's not going to vary very much, and you will plot it and you will see that it does plateau at some point. Or it should plateau. If it doesn't plateau, we have got a problem, and that's called a stress singularity. But again, there's a full tutorial dedicated to this. Anyway, so still don't know what, I haven't checked the strength of copper, but I'm pretty sure it's not going to be that good enough. So let's say I want to reduce the maximum stress. To do that, we'll want to, well, modify it and remove that cut. Okay, so go back to Workbench. And because I was a bit stupid when I created my model and the cut was in the sketch, it's not so easy to turn it on and off. And anyway, I might want to go back to the one with the cut. So what you can do is duplicate the system. It's quite common to work on slightly different geometries. So I duplicate the system. I'm going to copy it in a different page. Slower than I thought it would be. Hello. Here we go. So now, of course, and set up. And what I'm going to do is modify the geometry. So go back into Design Modeler. Going to Design Modeler. And what I will do is modify the geometry. And I will edit my sketch number 1. Okay, just by clicking on it, we are on it. Sketching, I like doing that. Look at it. And I am going to use the box selection to select all these points, delete them, regenerate, and have a fully done part. Okay, great, this is done. I can just exit. It's saving it automatically. I need to go and change the model. Things have changed, so it's whinging a bit. Yeah, sure. Let's reload. Let's update upstream. Read upstream. It's starting mechanical. I should have changed the name to no hole or something like that, made something more obvious. But now we go back into mechanical. back. Now that is what it had in memory. Don't worry, that's going to disappear in a minute. Hello? Yeah, it's reading it. Okay, there it is. Fine. Now the fixed support is still fine. The force again has not changed, and the mesh. What mesh have I got? The mesh needs to be updated. Yeah, 4 mm. So let's update the mesh to be sure it's a decent mesh. Actually, nicer mesh, much nicer mesh, very nice mesh. And let's solve. Done. Let's go straight to the deformation as not a bit less. And the stress is the stress has changed quite significantly. And this time, maximum stress is disappeared. Maximum is here. In fact, to be entirely honest with you, these stresses there are probably suspicious. Probably very dubious. They might actually be artifacts of the fact that we are using fixed boundary condition here. So there is no effect. Well, the Poisson's ratio is going to. There are some possible artificial constraints. So we would need to carry out a stress convergence study here, a mesh convergence study, improve the mesh, ideally improve it locally, to check whether that is actually a real stress or an artifact. But even though it has decreased quite a lot, so removing that all has made as the large effect. Another option, if we wanted to reduce that stress further, would be to increase the thickness or other size parameters, or possibly even change the material to make sure that the material that it can resist. To increase, so the stress would be the same, but the strength, therefore the factor of safety would increase. Okay, so again, any queries, please use the forum, and thank you very much. Bye.